Four of the major projects we're doing in the Center for Collective Intelligence include mapping the genomes of collective intelligence, measuring collective intelligence, combining people and computers to do collective prediction, and the Climate CoLab. In the project on measuring collective intelligence, we're applying the same statistical techniques used to measure individual intelligence, but using them now to measure the intelligence of groups. What we found is that just as with individuals, there's a single statistical factor that predicts the performance of a group on a wide range of tasks. We also found that this group collective intelligence is only weakly correlated with the average and maximum individual intelligence of the people in the group. It is, however, significantly correlated with three factors. The first is the average social perceptiveness of the group members. We measured that, by the way, by letting people see pictures of only other people's eyes and try to guess what emotions the people in the pictures were feeling. The second factor that was significantly correlated with the group's collective intelligence was the evenness of conversational turn-taking. So, for example, groups where one person dominated the conversation were in general less intelligent than groups where there was a more even distribution of conversational turns. And finally, we also found that the group's collective intelligence was significantly correlated with the proportion of females in the group. More females, more intelligent. Now, that third factor was largely explained statistically by the first factor. That is, it was known before our work that women on average scored higher on the measure of social perceptiveness than men. So it may just be the case that what you need for a group to be intelligent is a large number of people who are high on that measure of social perceptiveness, whether they're men or women. One thing we think is interesting here is that we may be able to use this measure of collective intelligence for real-world groups. For instance, what if we could give this collective intelligence group to a product development team or a sales team and predict how well those groups would do in the future? Or what if we could give such a test to a top management team and predict how well the managers would face a wide range of challenges over the coming year? Perhaps even more interestingly, what if we could use this test not just to predict how well a group would do, but to measure different ways of increasing the intelligence of the group? With individuals, it's possible to measure their intelligence and predict how well they'll do in various things like school or jobs, but there's not very much we can do to change the intelligence of an individual. But with groups, it seems eminently possible to improve the intelligence of a group. For instance, by changing the people in the group, or by changing the ways the group members interact, or perhaps, especially with larger and larger groups, by giving them new electronic tools for collaboration. So one of the things we think is particularly interesting is the possibility of using this measure of collective intelligence to investigate how to improve the collective intelligence of a group. One of the things about face-to-face groups is that there's an optimal size. Most people would say somewhere between 5 and 9 or something like that people. Beyond that, the group levels off or even gets worse in terms of its performance. But with online groups, with electronic groups, it may be possible to have much larger groups become more effective. For instance, it may be possible to have a group get more intelligent as it goes from 5 to 50 to 500 or even 5,000 people. As a thought experiment, for instance, imagine that you had 5,000 people in a football stadium trying to write an encyclopedia with nothing more than paper and pencil and the football stadium loudspeaker system. I think they could do something. They would be writing things down and standing in line to talk to editors, and every once in a while someone would come on the loudspeaker and say, now everybody do such and such. But I think they would get a lot less done in a given period of time, say 2 hours, than the same 5,000 people all using Wikipedia software. Another project in the Center for Collective Intelligence is investigating how to combine humans and computers to make better predictions than either could do alone. But there are certainly some cases where humans, because of their common sense, their ability to understand new kinds of input that are unstructured kinds of input that aren't available to an algorithm, there are certainly cases where humans can do a better job than algorithms. So in this project, we're trying to see how to combine them in ways that work better. For instance, in one study, we've used prediction markets as a way of combining human and computer predictions, where both the people and the computer agents are buying and selling predictions in the same prediction market. And we found that indeed the combination of people and computers together is slightly more accurate and quite a bit more robust. Another major project in the Center for Collective Intelligence is the Climate CoLab project. Now, many people would say that the possibility of climate change is a very significant problem, perhaps one of the most important problems our species faces today. It's also, I think everyone would agree, a very large, very complex global problem. Fortunately, however, at the same time we have this large, complex global problem, we have a new way of solving large, complex global problems that never even existed more than about 15 or so years ago. As examples like Wikipedia and Linux and Google illustrate, it's now possible to combine the intelligence of thousands of people all over the world at a scale and with a degree of collaboration that was never possible before. So that's our goal in this project, to apply this new way of solving global problems to the problem of climate change. To do that, we've created a website and a community using the website called the Climate CoLab. In this community, people from all over the world are developing proposals for what to do about global climate change. We've had several annual contests, including the largest one last year, where the 3 winning proposals developed on the website were presented at a briefing at the United Nations in New York and to a congressional staff briefing on Capitol Hill in Washington.